Okay, so we have one thing left to do, which is to basically finish the problems that we were working on Friday. So we'll start with an example. And the question will be, what point on the curve, or of y equals square root of x minus 2, is closest to the point 7, 0? Okay, and when you first look at that, it might seem a little intimidating. But let's just draw a picture and take things one step at a time. So, what graph is this? Shifted. How many?
2.
Okay. So here is our square root graph, right? Y equals root x minus 2. Looks like we need 7, 0 on here somewhere. So here's 7, 0. And now they want to know what point on this curve is closest. So if I'm just eyeballing it, it looks like if I go straight up, that's a little too much. But if I go a little bit to the left, that might be where that point is, right? Somewhere over here. Do I know the coordinates yet?
No.
So let's just label them as x and y. Okay? There's a lot of information in just this one question. I don't know if you've seen that. We have a graph, we have a point given to us, and what are we interested in? We want this distance to be what? What does it mean to be closest?
Small.
As small as possible. What's a fancy word that we've been throwing around? Minimum. D needs to be a minimum. Okay? Now, you guys should be pretty good at finding maxes and mins. The problem is we need an equation to do that with, right? So if I need an equation for D, let's write one. What is D going to be? So let's just plug everything in. So x minus 7 squared plus y minus 0. And now you start to see why we did what we did on Friday. We don't know how to find minimums with two variables, right? Do we have a way of finding y?
Yes.
What's y?
Y equals the square root of x minus 2.
Yes, this is the key. We know what y is already, so let's plug it in to the y equation. So we have x minus 7 squared plus root x minus 2. I'm subtracting 0 from there, so I'm not going to do anything with it. Squared. And now we'll clean it up and see what we can do from there. X minus 7 squared, what is that?
Square. Plus 45.
Plus, and if I root, but then square that, you get just x minus 2. So let's combine all our like terms. X squared, how many x's? Okay, plus 47. Okay, so we did a lot of work here. In section 4.2, they would have just said, here's this function, tell me the minimum. See the difference? We had to write the equation on our own, figure out a way to get it with just x's instead of x's and y's, but now we do the same thing we did earlier. What formula could I use which tells me x is what? Okay, good. So plug in negative b. So that's 13. 2a. 2 times 1.
2.
So 13 over 2. Okay, so now I'm going to make a big deal out of this because, look, a lot of these max and min problems, there's three important pieces. Number one, get an equation that you can minimize or maximize, which we did already. Number two, at some point you're probably going to use a shortcut to find, this is what we call the input, right? Does that make sense? The third thing you're going to do is answer the question. Well, duh, but what do you mean? Why are we writing this down? Here's why. There's actually two questions that I could ask you here. And people sometimes misread the problem or forget which one they're answering, and they get points taken off just for being silly about not reading details. The two things I could ask you to do here are to find the point that's closest, in which case your answer will be what? 13 over 2, comma, something, which we haven't figured out yet, but a point. You guys see my point? Okay. Or, if I don't ask you this, I could just say, find the minimum distance between this curve and this point. You see the difference? Find the point versus find the minimum distance. That tells you where to plug stuff in. Okay? So here, since we're looking for a point, my answer needs to be x comma y, right? I have x already. What's x?
13 over 2.
Y, do I have a formula for y? Where is it? Yeah, y is just the square root of x minus 2, so let's figure that out. X was 13 over 2, subtract 2. 4 over 2 is the same thing, right? So that's the square root of 9 over 2. Do we know the square root of 9? And then, of course, you know, because we want to make things rationalized, multiply, and then you get 3 root 2 over 2. This is our answer. Okay? Any questions on how we did that, or? Yeah?
What did you use the other one?
Good question. So let's do a side note here. If question is, what is minimum distance? Everything stays the same until you get to your input. So you still have to write the equation, you still have to write it with just x's, you still do the shortcut. All right? But now it's what you do with this input that makes the difference. What did we do the first time? The first time we plugged it into what equation? Y equals, because we wanted to know what y was, right? If we want to know what the distance is, do we have a distance equation somewhere? Where is it? Right here. So you're going to take distance equals the square root, and then you're just going to plug it in here. 13 over 2 squared minus 13 times 13 over 2 plus 47. And then you figure that out. Does that make sense? Let's finish it. Why don't we type that in, get a nice fraction. What do we get when we take 13 halves squared minus all that stuff, add 47? Anybody have it yet?
19 over 4.
19 over 4. Okay. So then square root of 19 is going to just stay square root of 19. Square root of 4 is 2. So this would be my answer if I asked what is minimum distance, plug it into the distance formula, and then you get root 19 over 2. Okay? All right, one more question that we'll go through, and then we're done with notes. I'll just kind of describe what's going on instead of writing out all the description, everything in sentences. But let's say you have a house. So I'm going to draw my best house. This is exactly what my house looks like. With a crooked door, yes. Yeah. And let's say adjacent to the house is a garden or a fence, or let's just say a yard or something. And the question is, if we have 200 feet of fencing available, what is the maximum area? Now keep in mind, we may not go all the way out to the edge of the house. It just depends on what dimensions we get. But this is kind of a great enough picture to write everything that we know down and then go from there. Okay? It's just a house. I mean, look, if you could just do this, aerial view, house. Fencing here, fencing there, fencing there. The key is writing down what we know and relating it to what we are inspecting. So if we have 200 feet of fencing available, how many sides am I using for the fencing here? Let's label them. Oh, I don't know. Why not X and Y, let's say. So 200 would have to come from what?
Y.
2x plus y. Good. So this is what we know, right? What are we interested in? Maximum area. So let's write down the area for that rectangular yard. What would the area be? X times y. We don't like things with two variables because this is not multivariable calculus. We just want things with one variable. Is there a way that we can maybe rewrite x times y as something else? What could I do up here? Divide?
Yeah.
Subtract sounds better. 200 minus 2x will equal y. And then, now you can take that, plug it into y. So area is going to be 200x minus 2x squared. Everybody good so far? Same 3 steps as before, right? Write an equation. Got it. Next we have to find the input, right? So here's our equation. Next we find the input. How do I do that? Well, you could flip it around. I think we can just go straight to it, right? What's the opposite of b here?
Negative 200.
Negative 200 over 2 times negative 2, which is our a value. 200 divided by 4, what's that going to be? 50. Okay. And now the third part was answer the question, right? I always like to relook at the question just to make sure I know where I'm plugging this into. They want to know what? Maximum area. So is there an area thing I can stick this into?
The area is
Right here. So area is going to be 200 times 50 minus 2 times 50 squared. Help me out. What are we going to get? $5,000. So 5,000 square feet, and we're done. Does anybody see what other question I could have asked instead of find the area, the maximum area? That's okay. I could have asked you for the input. What else? Okay, so let's say we know that 5,000 is the best area for our yard. Now what do I do? How do I build it? We have the perimeter, but you're close. So we're just going to put fencing randomly and say the math says 5,000, so here's my 5,000 square foot yard. That's a large yard, but what is it? The sides, yeah. Don't you sometimes want to know how long each side should be? So no, we're just going to put it up. The other question then would be, what are the dimensions that produce the maximum area? Does that make sense? In which case, if I asked you for the dimensions, you already got one of them, right? One of the dimensions is 50. The other dimension is y. And here's a formula that you could just plug it in and get your other dimension. Does that make sense?
Wait, so it'd be 200 minus... Can you do it?
Sure, okay. What if I said, what are the dimensions? Well, we know x is 50, and we know y is right here. It's 200 minus 2x. So 200 minus 2 times 50 gives us 100. So we have a 50 by 100 foot yard. Everybody good? Okay.